Good morning, ladies and gentlemen. I'm glad to attend this ACI Concrete Convention and on behalf of the team to present the structure design and the construction of the Chinese fan. The Shanghai Grand Opera House is located in the Expo Culture Park. It's the Shanghai Expo 2010 held there. The project is near to the Huangpu River, in Shanghai, China. The architecture design is inspired by an urban Chinese fan. It will be one of the most striking project landmarks in China. The total area is 146,000 square meters. The height is 45 meters. The outdoor spiral staircase functions as an accessible rooftop, an observation platform, and a city living room. It is structured topped out in October 2023 and will be open in June 2026. Both spirals rotate clockwise, forming an asymmetric double spiral staircase. The staircase consists of 68 steps. Each step rotates 4.3 degrees and has a height of 410 millimeters. The maximum cantilever length is 32 meters. So the roof is like an unfolding fan. In the accessible area of the roof, the small steps are partially installed, and through the arrangement variation, 136 millimeter high steps and landing platforms are formed. In the non-accessible area, the curtain walls on both sides curve upward to function as inner handrails. The Chinese fan comprises 3 distinct sections. One is the fan pivot, is yellow. The fan surface is blue, and the fan head is green. The fan pivot structure comprises a concrete core and 6 shells, and there's a top steel beam. The fan surface is a steel frame structure composed of circular main beams and radial secondary beams. Circular supports are arranged at the edge of the fan surface to ensure the stability of the overall structure. The cantilever length ranges from 9 meters to 15 meters, accounting for the architectural finishes and the ceiling construction. The effective height is only 725 millimeters. So the span to depth ratio is 21:1. The cantilever beams are prefabricated pre-stressed UHPC beams arranged radially and anchored to the concrete shell. Adjacent prefabricated UHPC beams are connected with cast-in-place UHPC joints to form an integrated structure and achieve waterproofing and the durability of outdoor staircase. The UHPC beams are connected flush with the bottom of the concrete 6 shell. The compressive strength of UHPC is 150 megapar, and the tensile strength is 8.5 megapar. Cross section is formed rectangular to a pie shape, minimizing the self-weight. Plus stress is applied to fully utilize the high compressive strength of UHPC. The UHPC cantilever beams are anchored into the concrete shell. Full-scale tests were conducted on 2 UHPC cantilever beams, and the maximum test load reached 1.7 times the design load, and the maximum deflection is about 770 millimeters. This is a test. Uh, 20 cantilever beams were randomly selected for in situ loading test. After the unloading, with no visible cracks or residual deformation observed on the beam. A total of 45 mass dampers were installed. The results showed a significant reduction in vibration by 47%. Through collaborative optimization of design and fabrication, only 2 sets of steel molds were used. A mass production was achieved using conventional concrete precast plants. This is a construction of concrete spiral shells and the installation of UHPC cantilever beams. There's a key construction milestones. The roof is started from July 1st, 2022, and it's topped out on October 21st, 2023. A summary of the construction. Yes, this is some photos during the construction. And the architectural finishes and the decoration was finished. And 2 weeks ago, the Global Engineer Congress was held in Shanghai, and engineers from more than 60 countries visited the project. The key innovation of the project is the seamless integration of architectural design and structural technology, and the structural test, in situ loading test, and the structural health monitoring, validating the safety and the serviceability of the new structure system. And the Shanghai Grand Tower Opera House marks the first application of UHPC technology in large-scale public building in China. And in short, it's a high-performance materials change structure as well as engineering, as a total design, full life cycle design, low carbon design. At last, I give thanks to the owner and the team, include architectural design, structural design, general contractor, UPC supply, and so on. Thanks. This is my presentation. Thank you for attention.